Hello mathematicians, we're now going to have a look at factorising. Factorising is a really important algebraic technique which is going to be really useful later on for finding the shapes of curves, for finding significant aspects of curves, even for doing parts of calculus. But in essence it's a simple idea. It just means that we want to find two expressions, doesn't have to be two, that multiply to give a current algebraic expression. So just like with numbers, we could think of, say, 12 as having factors of 3 and 4, two things that multiply together to give 12. Then algebraic expressions also have things that multiply together to give them. To take a trivial example, 2x is a 2 multiplied by an x. 2 and x are factors of 2x. It's usually much more complex than that, and there are some basic techniques that we need to follow. The first thing we usually try is to see whether there are any common factors, whether there are things that turn up in all terms which we can take out the front. So it's sort of the reverse of expanding. Now I'll just do some of these examples because I think you'll be okay with most of them. But please ask if there are any that you can't see the meaning behind. Sing out, we'll have a look at them in class, or send me an email and I'll put some more solutions on the OneNote. So let's say this one to start with. Now when I look at these two terms here, then, and so the equals is here because I'm going to write an equivalent expression. In each of these terms there is a y, there is an x, and there is a 2. So if I took 2xy out as a common factor, what am I left with? Well, basically, if you can't see it straight away, what you can do is simply divide each term by your common factor, 2xy. So if I took 4x squared y and divided it by 2xy, I would get 2x. And of course this bit would be 1. So that's it factorised. So two things that multiply together to give me this are 2xy and 2x minus 1. Next one down here. What do each of these terms have in common? Well, nothing numerically, because while 3 and 2 both go into 6, 2 doesn't go into 3, or 3 doesn't go into 2, so there's no common number. The only common letter is A, so the best I could do here would be to take A outside, which would give me a 6B plus a 3 minus 2A, which I can't simplify any further. Maybe this one here. So what do each of these have in common? Well, they have an x minus 3 in common. So if I take an x minus 3 out of x minus 3 squared, I'm left with an x minus 3. And if I take it out of this, I'm left with a 5. But of course I can write that more simply as x minus 3 multiplied by x plus 2. Looking for something different, maybe this one. A plus 1 is a common factor. So a plus 1 outside of this is a, and minus, now a plus 1 outside of a plus 1 squared is a plus 1. We just need to be careful with the brackets there. So a plus 1 outside of, this will be a minus 1, so a minus a will go. I'll just have minus 1, so it's actually minus 1 outside of a plus 1. That is this thing factorised. It's not only factorising, but it looks almost like it's simplifying. Okay, now if our expression to be factored has two terms, what we might do is consider whether we've got a difference of squares. So if we take the first example, the simplest one, when we look at these two, we can see that both of those are perfect squares. So the square root of 4a squared is 2a, the square root of 9b squared is 3b. So it's effectively one term squared minus another. So if I write it as 2a minus 3b, 2a plus 3b, I have factorised it. I've shown that it's a product of two things and have identified what those two things are. If I jump down to, say, this one here, same thing, it's obviously difference of two squares. So if I write down the two square roots added and the two square roots subtracted, then again, they're my two factors. Just have to be careful about the setting out. The one down below, same thing. So I've got an a minus 1 minus a b minus 2. You'll notice that it doesn't matter whether the first bracket is the plus or the minus. And down below, I've got the a minus 1 plus the b minus 2. Now in this case, it really needs some tidying up. So if I work on what's inside this bracket here, I've got an a minus a b, and for my numbers I've got minus 1 minus minus 2, so there'll be minus 1 plus 2, or plus 1 altogether. And for my second brackets I've got a plus b and minus 1 plus minus 2, which means minus 3 altogether. I really do need to continue on and do that extra bit of simplification for these ones. Maybe the last one here, x to the 4 minus 1, because square root of this is x squared, square root of this is 1, so I could write it as that. But then I'm not finished. I have to recognise that x squared minus 1 is itself a difference of two squares. So I could write that as x minus 1, x plus 1. There's nothing I can do with the x squared plus 1. So x to the 4 minus 1 in fact has three factors, which are these ones here. Okay, so in our quest to factorise things, we've seen that if we have any expression, any number of terms, our first check is there a common factor that I can take out? Second thing is we start looking at the number of terms. If there are two terms, and if they're perfect squares, and if one is subtracted from the other, we use our difference of squares. The next case is what happens if we have three terms. And our check here is to see whether it's a quadratic trinomial. In other words, a quadratic trinomial is something which has a highest power of 2, that's the quadratic part. Trinomial means it's got three terms. One term is going to be a variable to the power of 2, the other term is going to be a variable to the power of 1, and the third term is going to involve a variable to the power of 0, in other words, a constant. Now, there are two types of these, so there's a lot of language associated with this, which is something else that you need to have very clear in your head, so that we can talk maths rather than have to pack imprecise language around it. So the two types are monic, where the coefficient of the squared term is 1, or non-monic, where it's obviously not 1. And the monic type are the easiest to solve. So let's have a look at, say, a couple of these. So if we look at the first one, if I've got this, and there are lots of ways that we can solve this, but we recognise first of all it's a trinomial, it's got three terms, power of 2, power of 1, and effectively a power of 0, two lots of a to the 0. And there are several solution methods. The one that I'll encourage you to use is the product sum method, simply because it fits with a concept that we use later on in polynomials. If you are happy with the cross product method at this stage and you find it really difficult to switch, then go with that, but I would recommend the product sum method. So in the product sum method, we want two numbers that multiply together to give us 2 and add to give us 3. And just like in the cross method, you need to almost do trial and error. So two numbers that do this are 2 and 1. So we write a plus 2 and a minus 1. Now the biggest mistake that people make at this stage is that they've learned a process, but they've never really understood what the process is. So sometimes, assuming they get this far, they continue on and they remember something about saying, well, a equals minus 2 or a equals plus 1. But what they're doing there is that they're solving a quadratic trinomial. At the moment, we are just factorising. We're trying to find two factors, these two here, which would multiply together to give us this here. So if you're really having a sort of a mental meltdown, think about what factorising is. This times this gives us this, and just multiply it out. That times that, that times that, that times that, and that times that. And do we get the right answer? Well, actually I can see that we don't. I've made a mistake. That should have been a plus 1 there. So I'd love to say I designed that to show you the benefit of checking, but I didn't. What I did demonstrate was how easy it is to make a silly mistake. So be aware of that. Okay, let's have a look at this one over here. So same idea. When I factorise it, I want two things in brackets. W. I want two numbers that multiply to -8 and which add to -2. So if I had -4 and +2, that would do that. So these numbers here are -4 and +2. Now down below we've got all non-monic quadratics because the number in front of the x squared is not 1. Again, you may have different methods of solving this. I'm going to offer one, and it's the one that I'll work on in class. I'm not banning other methods. You get something that you understand and it works and it's efficient, then you do it. So again, I'll just do a couple of these. So I'll do the first and the third. And the method this time is very similar to the previous one. So instead of just x and x in here, it's 3x and 3x. But because that would give me 9x squared when I multiply it out, I always end up dividing by whatever the coefficient is again. So you can see that somewhere down the track, if it was 3x by 3x to give me 9x squared, and I divided that by 3, that would enable this 3x squared to come back. So it's not all just, a magic method. With the product and sum, that works the same, except that now I want a number or a pair of numbers which give me a product of this times this. The leading coefficient, that's what this one's called, times the constant, so that's +3. So two numbers that multiply to +3 and add to +4. And those two numbers, they could be a 3 and a 1. So if I put those in here, now one of the reasons that I like this method, apart from the application to polynomials later on, is that it gives me an instant double check. Because if I've got the right coefficients here, and it's easy to make a mistake and get the wrong ones, but if I've got the right ones, I should be able to take a common factor out of one or both of these, for that matter, which will end up getting rid of the 3 on the bottom. So for the first one, I can see that I could take a 3 out. There's nothing I can take out of the second one. And therefore, that 3 will cancel. My answer is this. The order of them, again, is unimportant, but it means that 3x squared plus 4x plus 1 is equal to the product of these two. So these are the factors. Okay, let's have a quick look at m. So down here, the method is again 2x, all over 2. I want two numbers that will multiply to give me negative 30, which will add to give me negative 7. So I could have negative 10 and plus 3. So negative 10 plus 3. I can see that I can take a 2 out of this bracket. So that will give me that. The 2 cancels. So I know I'm possibly on the right track. At least I'm not definitely on the wrong track. And so my two factors are x minus 5 and 2x plus 3. They're the two things which I say multiply together to give me this up here. And if I've got time and the energy, and I might have in an exam, then I could multiply those out and check that I do get that. Now, my last step in the processes that we're looking at so far is what we do if we have 4 terms. Well, after first of all checking whether there's a common factor, so that's always step number 1, if we've got 4 terms, we just see whether or not we can group them into pairs and then do some sort of factoring, rearranging, so that there's a common factor. It's a little bit of hit and miss, a little bit of observation, a little bit of black magic, but it's not that bad. So again, I'll do the bottom row just here. So with B, for example, I can see that these two both have an A in them, these two both have a B in them, which would only be useful up to a point, except that I can also see that when I take those A's and B's out, that will give me 2 terms which have x minus y as a common factor. Now, as you're probably already guessing, getting the signs correct once you factorize is something to be careful about. So here I can see x minus y as a common factor, so x minus y times what's left, which is an A from this and a B from this. Again, it makes no difference at all whether I write it as A plus B times x minus y or vice versa. The main thing is that these are the two things that multiply together to give me these. And once again, just as previously, the simplest way to check that you have the right factors, if you have time, is to expand them out, to multiply them out. For our next one here, I've got a u as a common factor here, a v as a common factor there. So if I take u out of these two, that will be u outside of p minus q. And here I've got v. Now if I just sort of blunder ahead for the moment, it's not what I would hope to do, but if I take v out, then I've got minus p from this bit and plus q from that bit. And I can see that this would be the same if the signs were swapped. So if this minus was a plus and this plus was a minus, I'd be set. So how do I do that? Well, I can now take, effectively, minus 1 out as a common factor. So my v becomes negative v outside of p minus q. Be careful, but be aware that this may be a possibility. And once we do that, then again, here's our common factor. What we've got here is u minus v, and we've always got our double check to multiply it back out again. Last one over here, we've got 2 sets of things here. We've got x's in these and not these, but I can see I've got an x cubed and an x squared. So if I took an x squared out of the first two, I would be left with an x plus a 4. And then when I look at these two here, to get that x plus 4, because I know that that's what I'd like to have, x plus 4, what could I take out? I could take out minus 3. So there would be my minus 3x and minus 12. So we've got x squared minus 3, x plus 4. Now, if this was a perfect square, I would say that you should go ahead and do difference of squares. But for the moment, without bringing surds into it, I would probably just encourage you to leave it as that, x squared minus 3. Down the track, different thing. Okay, so that was a long video, but an important video. A lot of techniques to get your head around, but all of them should be techniques which were known from junior school. So you might consider making absolutely certain that you know how and why those techniques work, when you would use them, and maybe a flow chart. Yeah, like if the thing has 2 terms, if it has 3 terms, if it has 4 terms, what's the thing that you always do first? That sort of process. So that this becomes, in a sense, almost a non-thinking exercise. The big idea is that I'm factorising. I'm looking at 2 things, or more, some things, there could be more than 2, which multiply together to give me an answer.